Greetings everyone. This is the tail end of the section 2.4 lecture that I would have done on Friday if I had been able to be in class. We have two problems to finish up, starting with this problem number 6. A quadratic function has exactly one x-intercept at x equals 2 and opens downward. So we're supposed to make up that function. That means what would the equation be? Well, first off, I'm going to draw a picture of what the given information is telling. It has exactly one x-intercept at x equals 2. And it opens downward. Since it has exactly one x-intercept, that must be the vertex. So the graph looks something like that. Well, we want to write something about the formula. We know that since it opens downward, the coefficient a is negative. A is less than 0. We know that since we have exactly one x-intercept, and that's the vertex, then the formula is going to have to look something like f of x equals Ra x minus h squared plus k. Exactly one x-intercept means that k is 0. Because if k is 0, that means that we have the vertex right on the x-axis. Now, the h is the x-coordinate for the vertex. And the x-coordinate from our graph is 2. So h has to be 2. So we now know that we have x minus 2 squared plus 0. And we know that this has to be negative. So it doesn't tell us any other information about what a could be. So a could be a negative 1/2. A could be a negative 50. We could have a graph that looks like this. If a were, say, larger in magnitude than what we originally drew, or if a were less in magnitude, you could have this. So, in other words, we're answering the second question here. There could be, in fact, there are infinitely many solutions. Now, here, a solution means a choice for the function f. We could satisfy the demand of the problem by saying a is negative 2. Just pick one. Of course, your friend could have said, or f of x equals negative 42 x minus 2. I'm assuming that your friend is a fan of Douglas Adams. Whatever we choose, the coefficient a does have to be negative, like we said above. Now the next problem problem number 7, we're given a revenue function, and notice that that revenue function is quadratic. Notice also that the a is less than 0. And further notice that you have a square term, a linear term, there's no constant term. Right there where you'd be expecting the c, you have nothing. So c equals 0. That means that the y-intercept is 0. In other words, the graph goes through the origin. Since A is less than 0, we're going to open downward, as I started to draw here. So the graph is going to look like this. Quadratic functions, graphs, or parabolas. This is a poorly drawn parabola here. There will be an x-intercept with the y-intercept at the origin. There will have to be another x-intercept somewhere over here, because if we're assuming that this is a realistic revenue function and that we would not be finding the maximum revenue in the second quadrant somewhere, which would make no sense. Now, the independent variable is p. It's taking the place of x. And we want to know what price should be charged to maximize the revenue. Well, you have the maximum there. The max value will be this on the r-axis, and it will be at this p. Now, there are two ways to do this. I like to work this problem both ways, just to illustrate a point. The first and easiest way is probably to find what this x-intercept is, and then halfway between the two x-intercepts you'll have your p. To do that, I would take r of p equals 0. In other words, 0 is negative 3/7 p squared plus 4900 p. And I would factor out I might be able to factor out at least a p and probably a pull out a negative p. Then I get negative 3/7 p plus 4900. Well, we know that this equation is true provided 0 equals negative p, or 0 equals negative 3/7 p plus 4900. This tells us that p equals 0, but we already knew that. This tells us that 3/7 p is 4900, or p equals, and now you get to see my incredibly ancient TI-85 calculator in action. I'll multiply both sides of the equation by the reciprocal 7/3, 4900, and I'm trying to hold this up to where the camera will focus on it, times 7 divided by 3. 11,433 and 3 repeating. 11433.3 repeating. Okay. So then we have that 11433.3 repeating there. That means the P to maximize will equal the average of the x-intercepts. So that will be 0 plus 11433.3 repeating divided by 2. I said plus, should write plus. So simply take the number that I have in the display, divide by 2, and get 5716.6 is repeating. So that's the price that should be charged to maximize the revenue. So it tells what P is. What is the maximum revenue? In other words, what is R of P? And to do that, I simply take R of 5716.6 repeating and substitute negative 3/7 5716.6 repeating squared plus 49005716.6 repeating. And of course this is not going to quite fit here, but it'll come close enough. On my calculator, what I would do is -3 divided by 7 times, and if I do second answer, it calls back the last result, squared plus 4900 times second answer. And I should get a rather large number, which I can force up here if I turn the page diagonally. So R equals 140058333 is repeating. I'm leaving these as so far as repeating decimals because I haven't wanted to deal with rounding off for sig figs. I probably ought to think about presenting this to like my boss. So let's see, that's 14 million, say $6,000. That would be a reasonable answer there. Okay.